So this worksheet covers vector components and vector addition. We're told that a new landowner has a triangular piece of flat land she wishes to fence. Alright. She measures two of the sides, A and B here, to be 80 meters and 105 meters respectively. Alright, and she uses those two vectors and the fact that these three vectors close, right? That A plus B plus C ends up back where you started, right? Vector-wise, that's saying this, that A vector plus B vector plus C vector equals 0. Alright, so here's A vector, here's B vector, and here's C vector. So we're asked to figure out what is C, right? Both the length and the orientation. That's asking us to find not just Cx and Cy, but to find the length of C and the direction that C is pointing, or this angle below west, right? South of west is how we say that. So we can use this fact. We can use that fact and rewrite it to solve for C. Right? If we solve for C, we have that C equals minus A plus minus B. Right? So now we can think about solving this using components. Alright, you can see the solution here is given graphically. And you could figure out the length of this if this is drawn correctly. But it's much more accurate to do this using components. Alright, so you can see here that C sub x is going to be minus ax plus minus bx, and C sub y will be minus a sub y plus minus b sub y. So I first need to break down a and b vectors into components. Let's start with maybe a vector. Alright, so we can look at a vector, and they have x and y axes set up for us here. So maybe I'll draw the x and y components of A so we can visualize better how to come up with this. So I can draw these two vectors, right? And these are the component vectors of A. Here's A sub y, and here's A sub x. And this angle here is also 21 degrees. Right? These are alternate interior angles of parallel lines. But I think you can argue that to yourself in any number of ways. So now, we just need to come up with how to write A sub x and A sub y. How to get that from the hypotenuse and one of the angles. So here it's useful to remember your trig. So I'll remind myself here, we've got SO, CA, and TOA. Alright, so I have the hypotenuse, and if I'm looking for x, that's adjacent to this angle, right? So the adjacent is cosine, so it looks like it should be A cosine of 21 degrees. So if I do that, A is 80 meters times cosine 21, which is 74.686 meters. And I can do the same thing for y. The A sub y is opposite, so that's a sine. So that should be 80 meters times sine of 21 degrees. And we should be careful here. A sub y is pointing down, so they actually need a negative sign. So that should be negative 26.765 meters. So I'm being a little sloppy with the number of significant figures I'm keeping here. Because these are intermediate results, I don't want to round just yet. In fact, the calculator gives you more digits than even this. Typically what I do is I write down a few, but when I do any other math with this, I'll scroll up on my calculator and grab the number with all of the digits going out as far as the calculator will go. And that helps to prevent round-off errors, right? These errors can accumulate through your calculations. So I have a sub x and a sub y. I should do the same thing with b. So slide this up a little bit. So b vector. So I want b sub x. So let's draw the components of b. So it looks like I can draw something pointing upward, something pointing to the left, b sub y, b sub x. Okay, so looks like I should just be able to write down b sub x is b times, it looks like x is the opposite, so that's sine. Right, so we'll say 105 meters times sine of 11 degrees. And that gives me 20.0 meters. And that's pointing to the left, so that's actually negative, so I need to be careful about that. That's negative 20.0 meters. B sub y is the other one, right? So it's the opposite, so it's, or rather it's adjacent, so it's a cosine. So that's 105 meters times cosine of 11 degrees. And I get 103.1 meters. Okay, so now I have the x and y components of both a and b, so I can add them together with some negative signs in front to find c sub x and c sub y. Okay, so let me slide this down just a little bit. So c sub x is minus a sub x. Slide this down just a little bit. So minus a sub x, that's a minus 74.686 meters, minus b sub x, which is a minus 20 meters. And when you do that math, you get minus 54.65 meters. And c sub y is minus a sub y, which is minus 26.765 meters, minus b sub y, which is 103.1 meters. Right, so you put those together, and you get minus 76.31 meters. So we're almost there. So now we need to put c sub x and c sub y together to get the total c. So if you remember, this is simply the square root of c sub x squared plus c sub y squared. Right, so I'll raise this to the 1/2 power because that's a square root. So c sub x was a minus 54.65 squared plus minus 76.31 squared. And for the length of this, I get 93.8581 meters. So I'll leave that for a second. We'll end up rounding that momentarily. Now we can find theta. Alright, so let's go back to our figure. And we have a choice. We can use any of our trig functions since we know all three sides of the triangle. Let's use tangent. Right, so tangent is opposite over adjacent. So opposite is the y direction and adjacent is the x direction. So it looks like I need to do arc tangent of c sub y divided by c sub x. So we'll fill that in, arc tangent of 76.31 meters divided by 54.65 meters. And you'll notice I put the positive values in here. Alright, that's because I'm looking for the inside angle of a triangle. Alright, so when you define trig functions, you don't, at least when you initially learn them, you don't think of using negative side lengths. Alright, if you plug a negative into your calculator, and for one or both of these, you'll get an answer. Alright, but it may or may not be what you think it is. If you take the arctangent of, say, a negative value, you might get the complement or the supplement of the angle you were looking for. Alright, so if you just plug in positive values, you can be sure that you're finding the inside angle of the triangle. Okay, so when you do this math, you get 54.4 degrees. So in total, C vector is 93.9 meters, rounded to 3 sig figs. So 93.9 meters at 54.4 degrees, and that's south of west. South of west. And that's our answer in total. We need 2 bits of information to represent a vector. Right? We solve for 2 bits. We solve for Cx and Cy, and that thoroughly described C vector. But we can also represent it as a magnitude and a direction. And that's what we were asked to do, and that's what we did.